Hello everyone and welcome to another video about MATLAB. As we saw in the previous time, we identified the different windows in the MATLAB working environment: the command window, the workspace, the current folder, the command history, the variables window. We are not gonna define them again so that we save some time. The left one window we did not identify until now, which is the editor window, but we will deal with it later inshallah, so let's leave it till it's time. Today we are gonna work more with matrices, 1D, 2D, 3D and multidimensional matrices. We will know how MATLAB defines or locate the elements within a matrix or within a variable. We will do some mathematical operations with matrices, and finally we will solve some linear systems. So let's begin so that we save some time. As we saw in the previous time, to define a variable we first name it. So let's name our variable a capital equals. If we want to define it as a matrix, as we said, we use square brackets. If we want to define it as a row, we can use spaces or comma. So let's use spaces 1, 2, 3, 4, 5. If we press enter, as we saw in the previous time, we see that the value of the variable appears in the command window. However, if we do not want it to appear in the command window, we can use the semicolon after the definition. If we press enter, we find that its value does not appear as previously. To define a coulomb, a variable as a coulomb, we name it equals square brackets, and this time we use the semicolon. So let's say 2, 3, 4, 5, 6, and after the definition again we use the semicolon so that its value does not appear in the command window. Hit enter, and we find that the two variables are stored now in the workspace. If we double click them, we find their values and their dimension. So here this is 1 times 5, and the other indeed will be 5 times 1. Clear? CLC. Those are, as we said, one-dimensional matrices. To define a two-dimensional matrix, say C, square brackets, and here we use both the space or the comma indeed and the semicolon to define both rows and columns. So let's define the first row as 1, 2, 3, 4, 5. Here we use a semicolon so that we define the second row, say 2, 3, 4, 5, 6. Another semicolon, say, to define a third row, 3, 4, 5, 6, 7. Let's delete 7 and see what happens if we press enter. Here we find that the dimensions do not match. What dimensions? Here if we count the columns we find them 5. Here we find them 5, and here we find them 4. So to define a 2D matrix, the number of columns in the first row has to be the same in the second, the same in the third, and so on. So if we just add here 7 and press enter, we find that the matrix is defined as 2D as we see. To define a 3D matrix, we have to add another page, and to understand what does that mean, we look at this picture. This picture illustrates the definition, or how to say it, the definition of multi-dimensional matrices in MATLAB. Here the first page is the first 2D matrix, the second page is the second 2D matrix, and so on, and the 3D, and so on. So here in C we define the first 2D matrix. To define a second 3D matrix, we tell MATLAB to add a second page. How to do this? Using two brackets. This operator tells MATLAB to take all the rows in the old variable, comma, another two dots to tell MATLAB to take all the columns now in the old operator, comma, 2. Here we specify the number of pages that we want to define, equal, say, let's take these as they are, copy, paste, and hit enter. Now we find that MATLAB added another page to the old matrix. If you look at it, if we look at its dimension, now it became 3 times 5 times 2. So here we have 2 pages, here we have 5 columns, and here we have three rows. Okay. To call some element in a matrix, we have to know how MATLAB gives addresses to the elements. If we double click any variable, we find that the variable window is divided into some columns, numbered columns, and some rows also numbered. So each cell is numbered by these 2 numbers. So the cell we stand on is addressed as the first row and the first column. This cell is addressed as the second row and the first column. This cell is addressed as the second row and the third column, and so on. So if we want, let's say, if we want to call this element in this variable, which is b, we just name the variable, and between 2 brackets we put the address of the element, which is here the third row and the first column. If we press enter, we find that the answer is 4, which is indeed the value of the stored in this cell, CLC, and so on. If we of course specify or call, let's say 2, the third row and the second column, which is empty here. If we press enter in the command window, it says that in index exceeds matrix dimensions. So we have to stick within the defined variable. Let's clear this. Okay, let's do some mathematical operations on matrices. As we saw here, we have A as a row, B as a column, and C as a 3D matrix. Let's define another variable called V equals, this time rather than specifying the values 1, 2 and so on manually, we will use another command, which is rand for random. And this command takes 2 numbers, the argument of it is 2 numbers, and in it we specify the dimension of the matrix we want to define. So let's define a 4x4 matrix, hit enter, and we find it defined like this. If we run the code one time, we find that the numbers of course change, because this generator generates random numbers. Here we have V as 4x4 as a square matrix. We can find the transpose as we saw in the last or the previous video, V prime. So it finds the transpose of the matrix. If we want to find the inverse of the matrix, we can use the command inv between 2 brackets, the matrix that we want to find the inverse of. Inv A, hit enter. I'm sorry, it's V, not A. V. Yeah. Here we find the inverse of the matrix. if we want to find the trace of a matrix, of a matrix, we use the common trace, and between its brackets, the argument of it, we specify the matrix we want to find its trace. So let's sorry, again, it's V. Okay, so it's 2.2017, and by calculating the trace, we calculate the sum of the diagonal elements of the matrix we specified. Great. If we have, let's say, if we have two rows, let's say 1, 2, 3, 1, 2, 3, enter, B equals, let's say 2, 3, 4, enter, we can find the dot product between of these rows, and to do so we use the common dot, and in its argument we specify the matrices or the rows we want to find their dot product. Enter, we find that it's 20. 1 times 2 plus 2 times 3 plus 3 times 4. Great. We can also find their cross product, and to do so we use the cross command, and also its argument we define the rows, and this time we wanna find the cross product of, let's say, equals, it equals -1 to -1. Let's clear all of this. Okay. Finally, we want to solve some linear systems. Linear systems on the form a matrix, let's call it A, contains the coefficients of the variables, which are linear indeed, times x, let's say x, the column variable, which contains the variables we deal with, let's say x1, x2, x3, and so on until xn. All of this equals another column contains the numbers after the equal sign. Great. So let's define a matrix. Let's say A equals rand, and let's make it 10 by 10. 10 by 10 matrix. So here we have a huge linear system, 10 variables, and let's define another column. Let's call it, or let's name it B, rand also, but here, as we said, we will define it as a column, so let's define it as 10 rows and 1 column. At enter, we find it like this. So here we have the coefficient matrix, and here we have the column which contains the numbers after the equal sign. To find the solution of such a linear system, we use the line solve command. So line solve, and in its argument we define the coefficient matrix, which is A in this case, and the column after containing the numbers after the equal sign, which in this case is B. If we solve this system manually, we will take a lot of time, but here, let's see, press enter, and we find the answer instantly, almost. By the way, we can calculate the time that MATLAB takes to solve such a system, and to do so we use the tick-tock command. Tick, then we use shift, or press shift enter, not enter, the command we want to run, which is in this case line solve, okay, and between its argument A and B again, and after the command we write tick-tock, enter. We wrote it wrong. Line solve. Okay. Hit enter. We find that the answer is the same, of course, as the previous one, and it took 0.038697 seconds. There is another way to find the solution of such a linear system, which is indeed, as we said, we wanna solve this system. A times x equals b. So we can just tell MATLAB to solve b over x, b over a, which indeed gives us x. So if we perform this calculation, b over a, and hit enter, yes, b, we find the same answer indeed. And we can also let MATLAB tells us about the time it took to find the solution. Take b over a, b, took, enter, it took 0.373 and some fraction of a second. So that's all for today. I hope it was useful. If there is any inquiry, please do not hesitate to contact me. Thank you.